Hey, alright, this video is just a review of water properties. So go ahead and get out your notes for water part 1 and part 2. And I want you to pay attention and watch this video really closely so that you can take extra notes and be prepared for your test. And y'all remember, as it is now, the test is next week, so make sure you're ready for that. Okay, so last week we said that, and you've already watched a little bit about these videos. Just so, starting with water part 1, just as a review, we've already said that water is a polar molecule. So take a second and see if you can remember what the word polar means. Polar means that a molecule has a negative charge and a positive charge. Okay, so water is polar, and that means it has a positive end, so the hydrogens are positive, and the oxygen is negative. Okay, so water also, in addition to being polar, water has the ability to stick together, and that's called cohesion. When water molecules stick to water molecules, that's called cohesion. Okay, when water molecules stick to something else, that's called adhesion. So water to water is called cohesion, and water to something else is called adhesion. Okay, water has surface tension. And surface tension is where the water molecules stick together, and it allows small little bugs to walk on the water. So that's an example of surface tension. Okay, water helps with temperature regulation. Temperature regulation. And really what it is water absorbs so much heat. And then when the sun goes down, the water releases the heat, and that maintains the temperature on Earth all day long, or all night long also. And this is a good thing. Water maintains its temperature well. Like, it doesn't go from 60 degrees to 80 degrees like it does outside in the air. So you know how some mornings you wake up and go outside and it's 60 degrees, and then by 2 o'clock in the afternoon, it's 80 degrees. Well, water doesn't do that. Water maintains the same temperature. It's resistant to change temperature. And so it does change, but it takes several weeks of cold weather for it to change. And that's good for the fish and the animals that live in the water, because they couldn't maintain the water temperature changing like we can. Okay, and then water does evaporative cooling. Evaporative cooling, and that's just where you sweat and water brings heat out of your body. And then water expands when it's frozen. Okay, so water expands when it's frozen. So all of these things about water. Water's polar. Water is cohesive. That means sticks to water. Water is adhesive. That means sticks to something else. Water has surface tension. Water regulates temperature, water has evaporative cooling, and water expands. All of these things are because of, and we'll actually change colors here, all of these things are because of hydrogen bonds. So those hydrogen bonds are really important, and they allow water to do all of the things we discussed in water part 1. Okay, so and that's really a review of water part 1. Go ahead and take out your water part 2 notes, and we'll discuss that. Okay, so water properties part 2. Get those notes out, and let's just review that really quickly. Okay, so on the first of it, it says that water is the universal solvent. And what that means is that it can dissolve or break apart compounds. So water is the universal solvent. So water can break apart solutes. And so look at your notes. It says that solutes is what's being dissolved. And write in your notes that a solute would be an example, salt or sugar. Okay, a solution is a substance possessing equal distribution. So like sugar and water, or Kool-Aid, or tea. A solution is already mixed up. When you get bleach at your house, it's 10% bleach all mixed in together. So solution is substance possessing equal distributions. Okay, we already talked about hydrogen bonds. And just do me a favor and write this out beside it. A hydrogen bond, so a hydrogen bond, let's just define hydrogen bond, is a hydrogen bonded to something negative. And that negative molecule is normally oxygen. So that negative molecule is normally going to be oxygen. And hydrogen bonds, of course, we know, are in water. Okay. So a hydration shell, water surrounding a molecule that can grab and dissolve. So a hydration shell is just on the outside of the cell membrane. It says water surrounding a molecule. So substance is dissolved and disappears with a hydration shell. Okay, and then remember it says oils, grease, and fats are nonpolar. And remember that nonpolar is hydrophobic. Like oils and things like that, they don't like water. They're water fearing. Okay, so hydrophobic, water cannot attach to the substance. And I want you to write in for me a molecule that's, or a substance that's hydrophobic is going to be oil or butter or grease or fat. Hydrophilic is a molecule that likes water. Water can attach to this. The substance loves water. And so if you remember back to the phospholipid, remember that phospholipid's in the cell membrane. Remember that the head of a phospholipid is water loving, and the tails of a phospholipid are water fearing. So this is hydrophilic. The head is hydrophilic, and the tails are hydrophobic. So take a second and draw the phospholipid on your notes and label which part is hydrophilic. The head is hydrophilic, and the tails are hydrophobic. Okay, so now we're done with that. Let's look at, it says chemistry terminology, acid and a base. And we did a lab on this yesterday, so you should know a little bit. This should just be a lot of review here. Okay, so an acid, on a scale from 0 to 14, 0 to 7 is an acid, and 7 to 14 is a base. Okay. It says an acid has lots of hydrogen ions. Okay, and a base has lots of hydroxide ions. So take a second and draw this in your notes, 0 to 14, and label the acid and label the base. And then 7 is neutral. Alright, a buffer, and that's the last part of the notes, is a molecule that resists change in pH. So you have a buffer in your body that won't let your blood get too acidic or too basic. Your blood has a pH of 7.4. So if it ever gets acidic, then the buffer can release OHs and make it more basic. Well, if your blood ever gets too basic, the buffer can release hydrogens and make it more acidic. So The buffer, you can make sure you understand, a buffer is something that regulates pH. So it says it resists change in pH. It can take in or give off hydrogens or hydroxides to maintain the pH. Okay, and the buffer in human blood is bicarbonate. So you want to know that word. Bicarbonate is the buffer in human blood. Okay, and then the last part of the notes is acid precipitation. And acid precipitation is just when the pH of like a body of water is too acidic, and that evaporates up, and then the acidic rain comes down. And so that would be acid precipitation, is when it rains and the rain is acidic, and that's bad for the plants.